And what we'll do is we're going to go ahead and create a couple groups. We're going to create one called forces. And we're going to give it a purplish color, remind us of the space warps. And we'll give another one, we'll just call it clouds, for lack of a better term right now. And what we'll do is we're going to use this box in an interesting way. We're going to go ahead and born two sets of particles inside this box. Let's call this born. Create a couple dynamic sets underneath that. We're going to turn off edit on the, or turn on edit on the fly so that we have to force update. We're going to go ahead, we'll remove that velocity, select this, cut it, and we're going to name this forces, and this one clouds. And we'll just go ahead and paste these in here. Set this one to be the forces. We're going to do a pistol shot of maybe 10 particles. And then in this clouds, we'll go ahead and paste that same setup. Except this time we're going to change the group to be clouds and pistol shot of, let's do 1,000 for right now. So forces, purple, clouds, let's go with kind of a bluish color. Okay, so right now you can see on our force we have left this on. Let's go ahead and turn it off for right now. Let's go into the forces, and we've got this volume position. We're going to update as random seed so they're not all being born in the same place. So the forces get born. Let's actually turn off clouds. There we can see the 10 forces that we had. Let's go ahead and update that so that we can get a different arrangement. Okay, something like that should be fine. And then we'll go ahead and enable the clouds so we can see those. Let's actually decrease their color a little bit, make it, there we go. Okay, and what we're going to do now is we're going to use the forces particles as forces to affect the clouds. The way we're going to do that is we do not want the all group there. We're going to disconnect those two guys for the second. We're going to use an initiator because we need to deal with two groups at the same time. We need to deal with forces and clouds. So we're going to use the p-pass AB. We'll set group A to be the clouds and group B to be the forces. We want the forces to be looking and saying, okay, we want the clouds to be looking for forces and say, anywhere there's a force within 50 units, go ahead and output either of us. And in this case, we want the clouds to be affected by this force. We're going to go ahead and set this up a little different. We'll set this to a sphere, and we're going to set a decay of, say, 20. And we're going to go ahead and expose the B particle position. Remember, B particles are the forces. So the force particles are going to be, their positions are going to be used by the clouds to originate this force. So what will happen here is, let's go ahead and born more clouds. Let's get 9,000. What you'll see then is kind of those areas where you can see a force, it's pushing those clouds out with a spherical force. Now if we want to go ahead and increase that force decay area, maybe match 40, which is, let's do 50, same as the p-pass AB. Now what we get is, as particles move around, they're going to become closer to some of these other forces, and you're going to see them each kind of get pushed away. Let's go ahead and take the force, You know what, let's do this with the force as well. Instead of having to go back and modify this distance all the time, then come to the force and modify his decay, we'll just go ahead and expose the decay and expose p passes AB's distance. And we'll create a float value here and feed it into both of them. And this will allow us to control two parameters from one location. Let's get rid of those two. And let's go ahead and set that to, let's do 40 this time. So within 40 units, those guys are going to get pushed away. Let's go ahead and do this though. Let's say, let's set this to radial sphere. We can see we start to get them all twisted around. Let's see here. Let's actually get a little bit closer. Now it's a little bit boring that they're all kind of going the same direction. One of the things we can do is we can come back to here where the forces were born, and we can change their alignment when they were born. We'll go ahead and use a standard operator called alignment, and we're going to go ahead and turn off or turn on edit on the fly right now because the computation is starting to catch up. So we'll go ahead and take this alignment, make his connection to those force particles. We're going to name this position born. We'll just call him forces. Makes it easy to quickly see in the viewport what it is we're dealing with. Those are the clouds. So back in forces, we've got this alignment operator now. It's going to set all these forces to be kind of randomly aligned. You can't see it now because they're all just dots, but if we go ahead and maybe drop a black box size shape on there and make sure our master dynamics showing mesh, let's come back here and say show me what they would look like as tetras with some size. Let's use a pretty big size. And now we've got a scrub to update. Let's have to go bigger. Okay, and now we can kind of see those purple guys are all kind of aligned differently. And let's go ahead. This is interesting. We've got some of them that are anyway, we can see these guys, how they're aligned now. They're all kind of pointing in different directions. Let's go ahead and we'll turn off that. Now, we'll leave their shape showing. Let's turn on the clouds. And this time let's come back into the force. And we're going to go ahead and use the alignment of those force particles. In order to get the alignment, first we're going to expose something on the p-pass AB. We're going to expose the B particle's alignment. Remember, the B particle is the force, the purple ones. And then we're going to go ahead and use the helper get direction. Get direction takes an alignment of something, and it can break down and say what their X, Y, and Z directions are. And let's go ahead and use their Z direction into the force. So now what will happen is these forces are actually kind of spinning around the direction that they're oriented. So we should get some unique results here. You can especially kind of tell this guy here spinning along this axis, whereas this one's spinning along here. You know what we're going to do? We're going to go ahead and cache this dynamic set. Definitely check the section on caching to understand this, but what we can basically do is come to the master dynamic, select the recorder, select a TPS file, specify file, and then we'll go ahead and hit record.